Hello everyone. In this segment, we'll discuss about system and classification of systems. In our previous video, we have seen what do you mean by signal, classification of signal, examples on classification of signals. Along with that, we have seen operations on signals. If you are new to our channel, please subscribe to our channel and share the videos. Now, first we'll define what actually mean by system. So basically, it is a set of interconnected components that performs an operation on an input signal and it produces another signal as output. So if you consider this particular block, here I am putting it or considering the input term as x of t, where we will get the output as y of t, and here I am keeping the term as t, that stands for transformation. Basically, transformation is nothing but any operation that is performed on input signal to give another signal as output. So such kind of arrangements are called as systems. Mathematically, we can write the same as output y of t is equals to, or it is obtained by performing certain operation that I am writing as t, that stands for transformation, on the input signal as x of t. So this particular term defines as system. Now when I come across classification of systems, we are having 6 sets of systems, including continuous, discrete, static, dynamic, causal, anti-causal, linear, non-linear, time invariant, stable and unstable system. So let us define the first one, continuous and discrete time system. Now how can you define it? A system is said to be continuous if its input and output both are continuous time signals. I repeat, a system whose input and output signals are continuous in nature is known as continuous time system. Here this is its representation. Similarly, we can define it for discrete time system also. A system whose input and output both are discrete time signals, or they are discrete in nature, such kind of systems are known as discrete time system. Mathematically, we can denote this as y of n is equals to transformation, that is an operation which is performed on a discrete time input signal as x of n. So this is the definition of continuous and discrete time system. Now we are having a second set of system, that is known as static and dynamic system. Now let us see what actually mean by static and dynamic system. So here we are having definition. What do you mean by static system? A system whose output depends on present input but not on past or future values of input is called as static system. That means we can say directly a system whose present output depends only on present input. Otherwise, the system is known as dynamic system. Now, when we relate the system term with digital electronics, so we are having a combinational circuit and a sequential circuit. As per as a combinational circuit, there the output was a function of present input only. Here it is a static system. So we can again define static system as memory-less system. Whereas if its output depends upon past and future values, it is definitely dynamic system, and we need a memory element. So all the dynamic systems are known as memory systems. So this is the broader definition of static and dynamic system. Now let us check whether the given system is static or dynamic. We have the first example, y of t is equals to x of t minus 2. Now in case of identification of systems, we have to consider the present input value, the past input value and the future values of the input. Now here I will tell you one short trick for identifying the systems. Now as far as for this one, let's consider the first duration as 0, and this t is equals to 0 can be called as present input. Now if it is a present input, the next location t is equals to 1 definitely becomes future, whereas t is equals to minus 1 definitely becomes past. That means for t is equals to 0, which is a reference, t is equals to plus 1 is its future input, and t is equals to minus 1, it will be its past input. So based on that, we can come across checking whether the given system is static or dynamic. For that case, I am considering three values. First, at t0, when I consider this, we will get x of 0 minus 2 as x of minus 2. Now if you see, we are finding the value of output at t is equals to 0, and it is a function of t is equals to minus 2. Now for 0, this minus 2 is past input. That means output depends on past input. Now our definition says that if the output depends on past or future, system is going to be dynamic. So we can write here this particular system is dynamic. Okay. Similarly, we can consider another examples as y of t is equal to x square t. Now again the same procedure. For t0, we will get y naught is equal to x square 0. For t is equals to 1, y1 is equal to x square 1, and for t is equals to minus 1, we will get y minus 1 is equal to x square minus 1. Now in both or in these three cases, here output depends upon present input. That means definitely this system is static system. Now I will come across the third example. Suppose y of t is given as x of t square. Now for t0, we will not get any of the term that for identification, because 0 square is 0, so y0 is a function of x0. Now when we consider t as minus 1, we will get y minus 1 as x of, now minus 1 square is going to be 1. Now if you see, we are finding the value for minus 1 and it is depends on plus 1, that is it depends upon future value. If it depends upon future value, definitely this is dynamic system. So by this procedure, we can determine whether the given systems are static or dynamic system. Now we have taken three examples of continuous time. Let us take one more example, and that is for discrete time system. I am writing it here. Y of n is equals to, suppose a x n plus b into x square n. This is the term which has been given. Again, if you see n0, this location, we have y naught as a x naught plus b x square 0. Output depends upon present input. Similarly, for plus 1, it is present. Y minus 1 will get a x minus 1 plus b x square minus 1. So this condition is entirely depends upon present input. So this system is going to be our static system. Okay. Now this is a static and dynamic system. Similarly, we can come across causal, anti-causal and remaining systems also. Now let us see this one. We have the second set of system as causal and anti-causal. How can you define a causal system? A system is said to be causal if present output depends on present input and past values. That means if any system whose output depends upon present and past values, it is known as causal system. And we are left with only one value, that is a future value. That means a system whose output depends upon future values is known as anti-causal system. Let us consider this with some example. First example I am writing, suppose we have y of n is equal to x of minus 1. Now again we can directly fetch whether it is causal or anti-causal, but we'll go with the same methodology first. Let us consider the three sets of values. At n0 we'll get y0 as x0. At n1 we'll get y1 as x of minus 1. Now here we are fetching the value for plus 1 and it depends upon minus 1. That means this is dependent on past, this is on present. So if I consider the last value n minus 1, we'll get y minus 1 as x of this value. Minus minus becomes plus 1, that means future. Now if in any of the cases, if it depends upon future, the system is said to be anti-causal system. Similarly, if I come across the second example also, we have that example y of n is equal to x of 4n plus 1. Let us consider the first set of value. n0 will get y0 as x of 4 into 0 0 plus 1 1 x1. Now this tells us whether it is causal or anti-causal. y0 depends upon x1, that is future value. So definitely this is anti-causal system. We'll see few more examples. Third example is y of n is equals to x of n plus 1 upon x of n minus 1. Say this condition n0, we are getting y0 as x0 plus 1 upon x minus 1. Now see, for 0, 0 is present and minus 1 is past. That means in first case it depends upon present and past. Let's suppose 1, it is x1 plus 1 upon 1 minus 1 is 0, x0. So present and past. Lastly, y minus 1, x minus 1 plus 1 divided by x minus 1 is going to be minus 2. So for minus 1 is present and minus 2 is past. That means in all the cases output depends upon present and past. That means this is our causal system. I hope you are getting whether how to identify the given systems are causal or anti-causal. Now let us consider the last set of example, as y of t is given as integration minus infinity to 2t x of tau into t tau. Now in order to fetch whether it is continuous or discrete, we have to put the values of t. Suppose I am putting it as t0, we will get y0 integration 2 into 0 as 0, this is x tau into t tau. Now we know that whenever we integrate, after that we put upper limit and lower limit. Upper limit is 0, so this is x0, minus lower limit is minus infinity, this is x of minus infinity. If you see, for 0, 0 is present, and for 0 minus infinity is past. So output depends upon present and past. Let us take one more example, one more value. This will be minus infinity to 2 x of tau into d tau. So when I put first value 2 over here, this will be x2 minus x of minus infinity. Now for 1, it depends upon 2, that means future input. So if in any case if you are getting future, system will be anti-causal. So this is how one can determine whether the given systems are causal or anti-causal. Thank you.